Welcome to the second episode on the series for creating a standalone GraphQL API. On this video, I will show you how to create a custom authentication flow, explaining different aspects like signup, permissions, and even token refreshing. Authentication itself is something that can become very complex when developing real-world applications. There are many different ways to do it, and definitely many more ways to do it wrong. Creating your own authentication flow might seem very difficult compared to just using an existing authentication service. But do not worry. I promise it's not as bad as it sounds, and by the end of this video, you will know one way to do it on your own projects. To those of you that did not watch the previous video, I will be using an API for a voting application. You can find the URL to the source code in the description below, so feel free to make a copy of it if you want to follow along with the video. Now, let's install a couple of dependencies for getting the authentication to work. You can find this on the description of the video. So let's start with the main dependencies. Once the dependencies are installed, let's proceed with the types of those dependencies. Okay, so now that we have the dependencies, let's create a file under the utils folder, auth.ts. And in here, you're going to be pasting the content of a gist that I will be leaving you on the description. So essentially, these utils will allow us to make the authentication process easily. Now, let's take a look at the authentication utils. The first thing you're going to see in here is the constants declaration. So you may want to isolate that so that future utils of our project have access to the configuration. Create the constants.ts file, and we can move this into there. Export default constants. And afterwards, we just uncomment this line. Second, we can see in here that there's a type declaration, and this defines the payload that we'll be using for generating tokens in our service. The next two concepts that I want you to focus on is the access token and refresh token. Both of these are going to be JWT generated by our API, but will be handled differently. The access token will be just returned on the response of our login. That way, the front end or the client can handle any way he wants to do it. And at the end of the day, that token is expected to live for a short period of time. That could be, for example, 5 minutes. Once the access token has expired, it can no longer be validly used for making requests to our API. And that's when the refresh token comes to place, because the refresh token can still verify the identity of the user for a longer period of time. And why managing this in a different way? Well, the access token can be directly handled by the client on local storage, for example. In a few words, by storing the refresh token as a cookie, we can make sure that is reducing the possibility of a cross-site scripting attack. Because when you have things on local storage, other applications might have access directly to the value that we are putting into there, and they could authenticate into the service pretending that they are you. By having this approach, there's still a chance that that might happen. So considering that a hacker gets access to your local storage and copies your access token, hopefully he shouldn't be able to do too much with that, because since it's expected to live for a short period of time, it will get expired and that person or program is no longer gonna be able to use that token. Instead, when you, the real user, keep using the application, the refresh token will come to place and renew your access token so that you can keep using your session safely. The create refresh cookie function that you see in here it's taking care of generating the appropriate options of the cookie depending on the environment. For example, if it's in production, it's gonna make sure that the cookie only works with HTTPS, otherwise it will disable that so that you can work locally. The expiration date, it's very important in here because it will be in charge of removing our cookie from the browser as soon as when it's no longer valid. So in here, I'm just using the MS library and getting from the constants the duration that is expected for that refresh date JWT. Additionally, if you wanted to make things even more secure, you could enable the same side option, recommended if your frontend and backend are not separate. For example, if you're using Next.js and you're not going to be making requests from outside of that URL. Finally, on the same function, we just set the cookie name to be refresh, we set the payload, and we set the cookie options that we generated. The remove refresh cookie is just going to use the context that we are passing, look for that cookie, and set an expiration date of now. That will make sure that the browser removes that cookie, because since we are updating the expiration date to now, it will no longer be valid for future requests. Create tokens, on the other hand, takes the two functions, assigns the same payload to both, and handles the part of assigning the refresh cookie to your response, and finally returning both of those tokens. The getUserID function will facilitate us getting the payload. Is using the connection, that's in case we are using subscriptions, and otherwise it will look for the authorization header and extract from the header the token itself, which then can be verified using the secret from constants, and from there getting the user ID. Last but not least, this function has the purpose of getting the cookie from the express request. This might be useful later on in one of our maybe endpoints if you're working on a REST API, or a mutation for the purpose of refreshing the existing session of a user. Now that we have more details about how the authentication utils work, let's create the inputs for our mutations. So go to your index.ts file under inputs and add these two for sign up and login. In here, just to give you some overview, in sign up, we are asking for general details about the user that is going to be creating an account. According to our schema.prisma file, this is what we need for a user. So just add those details in there, and for login later on, we are just going to require email and password. With our inputs in place, let's start the server so that the type generation starts working. Now, we need to actually declare the payload for our authentication. So inside the resolvers, create payload.ts, and inside payloads, add the following code. When the user signs up or logs in, it will get back the payload of the actual entity user and get the access token on the response. With this in place, go to mutation, and at the end of mutations, we are gonna add the following code. The only thing we are missing is to import the auth payload, sign up input, and the dependencies. We can take this from the utils. And what you can see in here is that as soon as the request comes to this mutation, it's gonna create that user using the information Prisma expects for the database. It's hashing the password with a configuration of 10 for default, and is using the create tokens utility for that specific user ID with the current context, getting an access token that can be sent back to the client that is requesting the new account. The next code that we need to add in here, it's gonna be for doing the login process. Once a user already has an account, he might want to log in later on. It's gonna take only the email and password, and after that it's gonna try to find a user that matches that same email. It could be another thing like a username, but for now we're just sticking to email. And if the user is not found, we can take advantage of the Prisma reject or not found option for throwing a custom error in case the user is not there. But if it's there, we can use the bcrypt to compare the password that is currently being sent with the password that was previously hashed and stored on the database. If it doesn't match, we just throw a custom error saying that credentials are invalid. And if everything looks good, we can reuse the create tokens utility for getting an access token and sending that back to the user. Now let's just take care of the inputs. And the last piece that we are going to be adding to mutations is the refresh auth mutation. So once we already sign up, as I was mentioning, the access token is going to expire in a short period of time, right? So we need to call again the API if needed to get a new access token, and behind scenes as well, a new refresh token will be assigned. So just import these from the utils. And if there is no refresh cookie detected from the headers, you can throw just a custom error indicating that there was no cookie present for doing that process. But if the cookie is there, we need to use Prisma to find the first user that matches with the user ID. Remember, this is part of the payload that we declared on the authentication utils. Now in here, once we have the user identified, we can just call again create tokens for that specific user ID with the current context. That behind scenes will give you a new refresh token as a cookie, and also return an access token that you can at the same time return to the response of the client. With the logic that we just added, we could already start using our authentication. But I will recommend to add the following mutation. The logout mutation will allow us to handle this scenario where a user not only leaves the account without use, but when it voluntarily decides to close the session. So in the front end, for example, you could have a button or something that triggers a call to the API. The API is gonna try to get the refresh JWT from the cookies. If it's not there, you can optionally throw an error, but if it's there, you need to make sure that that cookie is expired right away so that the browser cannot use it anymore for future requests. Now that we have our mutations declared, we need to make some adjustments to the server configuration. So go to your index file, and in here import cookie parser from cookie parser. And after your server start, app.use cookie parser. Now on your apply middleware, we are gonna be extending that, configuring the CORS. The origin really is gonna depend on the environment where the server is running. So make sure to have these declared. This will allow us to identify if it's under development. If that's the case, we can use the local origins, which includes the local host. Otherwise, define in here your own URL and that way the HTTP only cookies will be able to work correctly. If is def local origins, otherwise prod origins. And since we are passing credentials, this should be set to true. All right. Now, the last part of this will be to protect our queries and mutations, or in general, the resolvers with permissions. So under the source directory, create the permissions directory. And inside index.ts. For permissions, you could have the following set. As you can see in here, we are getting the context we have previously created. The isAuthenticated rule will check if the user object is already present in the context. And if that's not true, well, it means that you are not. So in here on the permissions declaration, GraphQL Shield allows us to specify the rule for all the different queries and all the different mutations. And later on, we can as well define exceptions to this rule. So the login, sign up, refresh, and logout are actually part of the authentication flow, and they should not be checking if the user is already authenticated. For passing this user object into the context, let's go to the context declaration, and we are going to be modifying the context creation. And here you will need to add user as null. And once we have the user ID, we can search for it on the database. Okay, so now when we create a context, we are gonna check if we can get the user ID from the headers, and if it's there, try to get the user from the database and set that object into the context. When we go back to permissions, we can see that that error went away and our rule is valid. For actually applying these permissions, we will need to go into the schema declaration. In here, we previously set the apply middleware dependency. We just need to pass the permissions. Now that we have the configuration in place, we can test our API. For that, I'm going to be using Thunder Client on VS Code so that you can see exactly what happens with the HTTP requests. To begin with, let's call the sign-up mutation with the following information. In the response, we can see that we get a valid access token, the user details, and also that the refresh cookie is present. That means that if we try to call the refresh mutation, automatically should detect our cookie and generate a new access token for us. And yeah, we see that there is a new access token and the refresh cookie was also renewed. Let's check the logout. And we see now that the cookie was correctly emptied. And last but not least, if our user wants to log in again, he should be able to call this mutation with just the email and password. And yeah, this authentication process is ready. I know that there are many things that can be improved in it, but at least it has set a foundation that you can reuse into your own project and customize accordingly. Let me know in the comments if there are any other topics that you would like me to explain, and don't forget to subscribe and share the video if you find this content useful. See you soon.